Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students, and welcome to CET JEE classes of continuity. We are in the third problem now. We have already completed first two questions on continuity, and I hope you are familiar with the conditions that we need to analyze to check whether a function is continuous or not. So first third question, the number of discontinuous functions y of x on closed interval minus 2 comma 2 satisfying x square plus y square is equal to 4. Alright. So the options are first 0, 1, 2 or greater than 2. What we need to first understand is the nature of the function here. So y of x is implicitly expressed in this equation. The equation is x square plus y square is equal to 4. So this is an implicit function. So let us write that in the form of f of x. Alright. So x square plus y square is equal to 4 is the given expression. So from this we get y square is equal to 4 minus x square. Now the function is y of x, or you can just write it as y. So you have got y square here. How do you find y? You have to take plus or minus on the right hand side. Okay. So you get two functions here. So one is root 4 minus x square, and the second is minus under root 4 minus x square. Now let us understand whether this is continuous or not. So the function here is f of x is equal to under root 4 minus x square, and also you have got minus of under root 4 minus x square. So this is a polynomial function, right? So it is not divided into two different branches. So there is no question of left hand limit and right hand limit being not equal. So obviously there is only one thing, directly find the limit. You don't have to go for left hand and right hand separately. So obviously limit will exist because it is a polynomial. Alright, there is no question of getting a 0 by 0 or infinity by infinity or any other kind of indeterminate forms. So obviously limit will exist. And what about the function value in this interval? You can take any point in between that, or even the boundary points are also can also be taken here. So if you take let us say 2, so you will get 0. So it is defined, it exists. You're not going to get infinity over here, right? So obviously the function value will be defined, and even the limit value at any point. All right, I'll just take a. So limit of f of x as x tends to a will be equal to f of a for every point a in minus 2 comma 2, right? And similarly you can check for negative of square root of 4 minus x square. Even there the limit value of the function will be equal to the function value at every point in the interval. So the function is continuous everywhere. So if it is continuous everywhere, what is the number of discontinuous values? 0. Therefore option A is the correct answer for the third question. So much for third one. Now let's move to the fourth question. In the fourth question, what is given? F of x is defined like under root 4 plus x minus 2 divided by x, where x is not equal to 0. Obviously x should not be equal to 0, otherwise the function is not defined. Alright. So what is given is the function is continuous at x is equal to 0. Then we need to find f of 0. Alright. So if you try to find f of 0 directly, disregarding this condition, alright, so just substitute 0 here. So you will get 0 by 0, which is not defined, correct? It's an indeterminate form. So you cannot find the function value at 0 because x cannot be equal to 0, right. Therefore, we have to use the conditions of a continuous function. What do you mean by a function is continuous? Limit of f of x as x tends to a is equal to f of a. So that's the condition we got to use here. Since the function is continuous, limit value of the function will be equal to the function value at the given point. So let us find the limit of f of x. So that will give you the function value at the specified point, the point being 0 here. So let us write f of 0 as limit x tends to 0 f of x, and let us now replace f of x, right. So f of x is square root of 4 plus x minus 2 divided by x. So to find f of 0, now we got to find the limit of the function f of x. So let's continue with this. So how do you find the limit of this? Here, if you substitute x tends to 0 here, you will get 0 by 0, which is an indeterminate form. That cannot be the answer. So we have to rationalize the function here. So multiply and divide by under root 4 plus x plus 2 divided by square root of 4 plus x plus 2. So that's the thing, we have to multiply and divide in order to rationalize the term here. So now let us use the formula of a minus b into a plus b, which is a square minus b square. So this will turn out to be 4 plus x whole square and minus 2 square, that is 4. And in the denominator, actually you don't have to do anything. So keep it that way. Now, what about this term? Square root and square will cancel each other. Hence, you will get a simple term there. So this is equal to limit as x tends to 0, 4 plus x, and you have got minus 4 here, and denominator is unchanged. Well, on the numerator you have got 4 and minus 4, which cancels with each other. So you will be left with x in the numerator and x into square root of 4 plus x plus 2 in the denominator. Now again, if you substitute 0 in place of x, you will get 0 by 0 indeterminate form. So first get rid of that term. So you can cancel out now. So cancel x, right. So now you can apply the limit and you won't get any indeterminate form. You will get the value of f of 0 here. So now let us substitute 0 in place of x. So that is like square root of 4 plus 0 and plus 2. Now this is square root of 4, which is 2. So in the denominator you have 2 plus 2, that is like 1 by 4. Hence 1 by 4 is the answer of f of 0, which is equal to limit of f of x as x tends to 0. So option B is the right answer for the fourth question. Having solved that, now let's move to the fifth question. Here again f of x is given and it is said to be continuous at x is equal to 0, and what we need to find here is the value of k. Well, so here you have got sin pi x by 5x when x is not equal to 0. First understand the meaning of this. What is the meaning of x is not equal to 0? Either x is less than 0 or x is greater than 0. So both left hand limit and right hand limit are covered in the same function. So you don't have to go for different limits here, and to find the value of k you have to use the third condition. And what is the third condition? We just used that in the fourth question. Let's use that again. So the third condition of continuity is as x tends to a, f of x is equal to f of a. So let's find the limit at the specified point, and what is that point here? At x is equal to 0. They have given that the function is continuous at x is equal to 0. Therefore, limit must exist at x is equal to 0. And what is f of x? When x tends to 0. See, the meaning of this is x tends to 0 and x is not equal to 0 there. Alright. So, it is either from the left hand side of 0 or from the right hand side of 0. You are just moving towards 0 and not attaining 0 there. Alright. So, we have to use this function in place of f of x. So, that is the sine pi x divided by 5x, and that is equal to f of 0. And what is f of 0? F of 0 is k, because at x is equal to 0, f of x is equal to k. Therefore, f of 0 is k here, and to find the value of k we have to solve this limit. Now, which formula can you use here? You have a formula of trigonometric functions, that is limit of sin x by x as x tends to 0 is 1. So, this is the formula we can apply to this problem, and we have to do some manipulations here. Alright, so you have got pi x as the angle in the numerator, so you must have that in the denominator as well. You have got x already, so what else you need is pi. So, multiply and divide by pi. So, that is the step we are going to do next. So, limit x tends to 0 sin pi x. This 5 we can write it separately, you do not need that. Multiply by pi and divide by pi. Alright. So, 5 by pi is a constant. So, you can take it out of the limit. So, if you take it out of the limit, that will be pi by 5, okay, that will be inverted in the numerator, and limit of sin pi x by pi x is what you will be left with. So, now what is the value of limit of sin pi x by pi x as x tends to 0? The value is 1. Therefore, pi by 5 into 1 is equal to k, and hence the value of k is pi by 5, and that is in the option B. Therefore, option B is the right answer for the fifth question. Now, let us look at the next set of problems. Well, dear students, let us look at the sixth question on continuity. The function f of x is equal to modulus of x plus modulus of x divided by x is. Just look at the four options. First option says that the function f of x is discontinuous at origin. What do you mean by origin? At x is equal to 0, because modulus of x divided by x is discontinuous there. And option B, discontinuous at origin because modulus of x and modulus of x by x is discontinuous. Then the option C, continuous at the origin. Alright, and the fourth option, discontinuous at the origin because mod x is discontinuous there. So, now what you need to decide is whether the function f of x is continuous, that means both modulus of x plus mod x by x is continuous, or any one of them is discontinuous or not. So, let us analyze what does this function look like. So, first what is mod x definition? So, modulus of x is defined as minus x if x is less than 0, and it is x if x is greater than or equal to 0, right. That is the definition of modulus function. And how does the graph look like? The graph is of this form, right. So, you have got y axis and x axis, and the first branch you have got y is equal to x here, and the second branch is y is equal to minus x. So, clearly the function is continuous at 0, right. So, it is not differentiable at 0, but the function is continuous. The modulus function is continuous at 0. It is continuous everywhere actually, right. Secondly, what is mod x by x? What about this function? So that is once again, if you divide it into branches, what about when x is less than 0? See, when x is less than 0, what happens to modulus of x? It is minus x. So that will be minus x by x, right? Next, what if x is greater than or equal to 0? So if x is greater than or equal to 0, in place of mod x, you got to write x, hence that will be x by x. So in other words, this will be minus 1 because you can cancel out x here. So this is minus 1 when x is negative, and it is plus 1 if x is greater than 0. But what about at 0, right? So at 0 the function is not defined here, correct? So modulus of x divided by x is not defined, so only at greater than 0 you will get 1. Well, now how will the graph of this function look like? So you have got x axis and the y axis over here. For all the negatives, the value of the function, value of y, the output is minus 1, correct? So for all negatives, minus 1, minus 2 and all those values, y is minus 1, and at 0 you don't have any value there. And what about the positive values? So for all the positive values of x, y is 1, so you will get the graph over here. Well, so does it look like a continuous function? Obviously no. So from the graph it is evident that the function is broken at 0. So you come from the left hand side and you reach almost to minus 1 and you stop there. You don't go till 0 because at 0 it is not defined, and after 0 you will continue along this direction. Okay, so the value of y will be 1 for positive values. So it is discontinuous at 0, it is not continuous. Left hand limit will be minus 1 and right hand limit will be 1. So when I explained the concept of continuity, I took the example of this function. So I explained that it is not continuous at 0. So now you know that the function mod x by x is discontinuous at origin and modulus of x is continuous at origin. So which option says that? So the first option, it says that the function f of x is discontinuous at origin because mod x by x is discontinuous. So first option is the correct answer. So that explains the situation clearly. So all other options are saying that either both are discontinuous or both are continuous or mod x is continuous, and all the three options are not correct. Therefore, option A is the right answer for the sixth question. Well, dear students, let's move to the seventh problem. If f of x is equal to 1 minus cos x by x when x is not equal to 0 and k when x is equal to 0, if that function is continuous at x is equal to 0, then the value of k is. So here we got to use the third condition of continuity, which says that limit of f of x as x tends to a or 0 here is equal to the function value at the given point, that is f of 0. So we have to find the limit of f of x, and do we need to find the left hand limit and right hand limit separately? We don't need to, because for both x less than 0 and x greater than 0, the function is 1 minus cos x by x. Alright, you don't have two different functions for less than 0 and greater than 0 separately. So you don't need to find left hand limit and right hand limit separately. So just one limit is sufficient here, and that must be equal to the function value at the given point, then only the function will be continuous. Now it is given that the function is continuous, hence this condition holds. So let's continue with this condition. Now let me replace f of x here, f of x being 1 minus cos x divided by x, because we have x tends to 0, So x tends to 0, x is approaching to 0. So x will be either less than 0 or greater than 0. Hence the function is 1 minus cos x by x, and that's equal to f of 0. So what happens to f of 0? F of 0 is k, because when x is not when x is equal to 0, f of x is equal to k. What does that mean? F of 0 is k. So now this is a standard formula. What is 1 minus cos x divided by x as x tends to 0? So the value is 0 here. So the limit value is 0, and that is equal to k. So that means the value of k is 0, which is in the option C. Therefore, option C is the right answer for the 7th question. Well, let's move to the 8th one. 8th one looks similar, except for the denominator here. You have got x square. So what change will it have? Let's look at that. Well, once again the function is said to be continuous at x is equal to 0, and you have got x not equal to 0 here. So which means x is less than 0 or greater than 0. For both the function is 1 minus cos x by x square. So once again the same condition, limit of f of x as x tends to 0 is equal to f of 0, right. So what is the function here? The function is 1 minus cos x divided by x square, and that's equal to f of 0. By the way, what is f of 0? F of 0 is k, right. So just like the previous problem, so write k here. Now what is left is finding the limit, and when we solve the problems on limits, this formula was highlighted there, and the formula was cos 1 minus cos px divided by x square. And what's the answer of this limit? Okay, so the answer of the limit of this function is p square by 2. I hope you remember this formula. All right. So if you don't remember, please go back to the videos on limits and check the formula again. So there were two formulas which were similar to each other. Please remember the answer there. Okay, p square by 2. Hence, now that formula is comparable to this expression now, and in place of p we have got 1. Therefore, the limit value of this function will be 1 square, 1 divided by 2. So hence the value of k is half, and that is in the option A. Therefore, option A is the answer for the 8th question. All right. So that's it for the concept of continuity, and in the next class we will begin with the differentiability. So thank you for watching.
Don't forget to like our video and subscribe our YouTube channel for all the updates.